Hi everyone, today we're going to talk about data frames and we're going to go over a few plots. And then there's a few side notes, just important little things to know that we haven't covered yet. So the first of which, and I don't think this is in the manual, but I thought it was important, is talking about your working directory. So this is the kind of like the default location on your computer that R is going to pull things from and save things to automatically. So if you want to know what it is, you can just run the command getwd, open close parentheses rather, with nothing in them. And if we run that, we can see what my working directory is. So my working directory right now is just kind of set to my general user file. And so that's not usually where you want your working directory to be. You probably want to be saving to a specific folder that you're working out of whenever you're in an R session. Or maybe for you, in terms of like taking an exam or something like that, you might want to just be saving things to your desktop so they're easy to find. So if we want to do that, we're going to have to set our working directory to be something else. So if I want to set my working directory, it's very simple. We do set wd. And to show you how to find out what the correct path is to my working directory, I'll show you how to do that from scratch. So first you're gonna type quotes. The file paths always have to be in quotations. So next, if I'm not sure what, maybe like what the next thing to do is, maybe I don't know the path of my directory that I want off the top of my head, what I can do is press tab and it'll come up with a menu of options for me. So this will make it easier for if you don't totally know what path you want to choose, or you're just not used to having to type this out, you can press tab and it'll come up with these options, and you can just select from them. So maybe I want to do desktop. We can do that. And you'll notice that it didn't just type the word desktop, it put that backslash in there. And so that means that I'm going to, that's how we divide the different like pieces of our path. I don't know the actual technical word for it, but so basically whatever file I'm going to save, if I wanted to save it on my desktop, I would put desktop, this backslash, and then write out the actual file name that I want. So if I wanted to save it to my desktop, I could just set my working directory here. But maybe I want to set it to a specific file. I can do that by pressing tab again, and we can see that I have a bunch of different stuff. We're going to go to my Social Science 3A folder because that's probably the one that I want to choose. And yeah, I think I'll just save things there, but I will just show you, if I press tab again, it also gives you the different options that I have in this folder. So I have our, the lab documents and quizzes. I could save it in one of those folders if I wanted to. I have folders in those, so I could save it in those and just keep going. Either way. So I'm getting rid of this last backslash because I just want to save it in the Social Science 3A folder, and I don't need to go any further than that. So that will be my new working directory. I can press Control Enter here, and now my working directory is set. If we're not sure if we set it correctly, we can run getwd again on it, and we can see, yeah, I did set it correctly. This is where things are now going to be automatically pulled from, and where things are going to be saved automatically if I save them in R. So just an important little aside to know. Okay, moving on to Chapter 6. We're going to talk about data frames today. So we'll start with seeing why data frames are used sometimes as opposed to matrices and what the differences are. So here I've set double F to be a matrix of 4, repeating 4 times with 2 rows. So if I run that and we look at it, it is 4 times with 2 rows and therefore 2 columns. So let's say I want to change the element in my first row and first column, that's why we have 1, 1 here, to the word 4. If we do that, and then we look at what the change was that we made, you can see that it's not just that the word 4 was inserted here. All of our other 4s now have quotations around them. And what that means is that it is those individual elements are now characters. So we don't necessarily want our numbers to be coerced to characters every time we introduce a character into our data. And the reason that this happens is that matrices can only contain one type of data at a time. You can't put multiple data types into your matrix. And so that is where data frames come in. So data frames can take multiple data types at the same time, but they're very similar to matrices. So they have columns and rows and can be subsetted in similar ways, as we'll see. So we're going to make a data frame here. First, we're going to start out with our names, which is going to be a matrix of Amanda, Brandon, Cynthia, Daniel, and Elizabeth. And we're going to have 5 rows. That means that we're going to have a column matrix because it's going to be one column. I don't think I covered that, so let me just show you. Oh, sorry. Right. So names now is a column matrix, meaning it's made up of only one column, and it has our names in it. Now we're going to make a similar matrix, but this one is going to be numerical or numeric. So this one is going to also be a column matrix, and so will the next one. These are going to be midterm grades and final grades. And then now we want this all together in a like a grade book type of deal. So what we're going to do, rather than trying to make it into a matrix by C-binding our individual column matrices, which would then coerce our scores into numbers, which means we couldn't run, they would coerce our scores into characters, which means we couldn't run any summary statistics on them. So, that's obviously something we want to do. So what we're going to do is do scores, and then it's going to take, instead of matrix, the command is going to be data.frame. Really important to remember that period there, otherwise it's not going to work. So data.frame, it's going to then be made up of names, midterm, and final. All you have to do is list your columns in the order you want them in, and it will string them together. So we do that. We can look at scores here, and it has put together our names, our midterm, and our final, and you can notice that it also keeps the names of the matrices as our column names now. Okay, so now we can also put together 2 other ones. So we're going to do this by C-binding our midterm and our final. So if we do this we're going to make a new, matrix, as we'll see. So remember, when we C-bind 2 matrices together, we get a matrix. So let's say we want to just turn those into a data frame. We can do that by doing, instead of C-bind, data.frame on names and test. So now we're using our new matrix in place of doing them separately and adding it like this. So scores 2 will be a data frame of names and our new matrix test. And we can see here, so because our individual, we didn't use individually named column matrices, we don't retain those names. So now they get replaced with X1 and X2. And that's because they were just individual columns from a larger matrix. So something to keep in mind. If you have this, you do want to usually have your column names be more informative than just X1 and X2. Especially if you're ever sharing your code or sharing your data with someone else, you definitely don't want to have that in there. It's not useful for anyone else. So how do we change those column names? It's pretty simple. So we do call names, or short for column names. Then we do scores 2. And then this is important and something that I actually, personally would mess up for some reason a lot when I first started. You need to have the brackets outside of it, because what this is doing is call name scores 2 is actually calling a vector, because those column names are stored as a vector. So call name scores 2, you can treat it like it's the name of a vector, and that's why you have outside of it your brackets that are then subsetting that vector and not subsetting it the way you would subset a data frame or a matrix. That's why it only has a single number here. So this is saying for the vector column names scores 2, I want the second element, which is the same as saying I want to set the second name of my data frame scores 2. Okay, anyway, so we're going to set that to midterm. And then we're going to set the third one to final. And we can see now here, if we print out again, those names have been set. So we're good to go. Okay, so checking the data types. Obviously, scores 2 is a data frame, or, well, data.frame in R, because that's what we set it up as. But we can also check what the classes are of our individual columns. So if we check for names, we can see it's a character. It's a character vector. Your data frame, you can think of it as being made up of separate vectors, kind of. Also to point out this $sign. This is something you use with data frame specifically. So if you can subset a data frame using square brackets, which I'll show down here, but you can also call the names of individual columns, specifically columns, in a data frame using the $sign, and then whatever the name of the column is that you want. So that's also why it's important to have your columns actually named. And just to point out, so if I'm typing this out like scores 2, you'll see that this menu pops up. If I click on it and do a $sign, it comes up with my different options. So I can be nice and lazy and not have to type those in by hand. I can just click on names and then it'll type it out for me. Okay, so here we want to know the class of the column in scores 2 labeled names. It's a character, midterm is numeric as we would expect, and final is numeric. Okay, we will talk more about different classes in a little. So next we want to talk about reading in data frames. And this is also why I wanted to touch on working directories and paths a little bit earlier. So gonna show you how to read in a data frame in 2 different ways. Although these 2 different ways are specific, well, this one that I'm going to show you first, this will work in R if you're just using base R. However, the second one I'm going to show you will be specifically for RStudio, and this is if you're really not comfortable typing out paths yet and you feel like you might mess it up. I don't want students to panic on a test because they feel like they can't import a data set into R. So first way to do it, and this is the way that, I mean, most people would prefer because you're actually just typing out the code, it's faster. You're going to set the name of the data frame you want. So if you're reading in a CSV, some kind of data from maybe Excel or from some other kind of file you have to name it. So here we're going to do CEXP, short for commute expenditure. So we're naming it first, as you do with everything in R, really. So naming it, and then it's going to get read.csv. This command's really important. So if you're going to be trying to load in a data file, you really want to remember read.csv. This is how you're going to read in a CSV file. There are other data types you can read in, but we're just going to focus on reading in CSVs. They are the most common, and part of this is because CSVs are, you can open them in a lot of different programs. So they're just very common. You can convert or save as your Excel files. You can save them as CSVs and then load them into R. So the data you're going to be working with is in a CSV form. It is attached to this video so you can follow along with it. And it's going to be read.csv and then the path for that file that you want to read in. So here, what do we want to read in? So for me, it is in desktop, which I typed this out actually before I set my working directory, so I don't need this first part. we can actually just delete that first part because my working directory is already set. So instead, what I can do is just type out lab documents, lab 10, lab 10.2, commute expenditures.csv. That's going to be my path, but let's go over again how to get that if I don't know what it is, right? So I need to read in a CSV. I have to go find it. So what do? I type out my quotations to make sure that I can properly write out the path name. I press tab, and let's see, where do I need to go for this? I believe it's in lab documents, so we're gonna press enter on lab documents. We're gonna press tab again. This one is under lab 10, so we're gonna press enter again, press tab. This one is going to be in lab 10.2 for me, so I press enter. And then one last time, if I press enter, I can now see my file name. So do I want to put in vote results or commute expenditure? I'm going to put in commute expenditure, press enter, and I now have typed out my whole path, no problem. So if I just run this line quickly, I will get my CSV to load in. It's pretty fast, so that's nice. And we can see we have a data frame right here. Also, a quick aside, if you are using RStudio, you can look at your data frames by going over to it in your environment. And under the value column, you can see that the little white hand shows up. If I click on that, it will allow me to view the data frame in a separate window. So just something to know. I oftentimes like looking at my data in a separate window like this. Maybe I'm just too used to having learned Excel when I was younger, but either way, something I prefer to do sometimes when exploring my data. So this is a rather small data frame. Sometimes you have much, much larger ones. And so how do we kind of get a sense of it without having to look at the entire thing? This is where head and tail come in. So if we do head, it's going to show us the first 6 rows of our data frame for each column. So we can see that this is the first 6, but if I just opened a CSV and I don't really know what's in it, this would give me a good sense of what kind of data do I have. We can also do the same with tail, but this will look at the last 6 rows, and it'll give us again for all of our columns. Okay, so I said I would show another way to read in a CSV, and I do want to show that. So this is for RStudio. If we go to our little environment over here, I want to load something into my environment. So I'm gonna go to this open folder or load workspace, and I'm gonna click on it. And here, it's going to open your working directory automatically. But by doing this, what I can do is actually just select from my Finder window. I can go just by clicking to lab documents, lab 10, lab 10.2, and commute expenditure, and I can open it this way. So, opening a CSV. That was if I had an R file. I can open a CSV, my bad. I don't usually do this through the windows, but you can import it as a data set. So here what we're gonna do is do from text base. This is how you would load in an Excel file if you want to load in an actual Excel file. I don't really recommend doing that, but you can if you want to. If you have it in CSV form, you're just gonna do from text base. And then, there's the pop-up menu for that. If you click on it, then what it'll do is open. Great, and it'll come up with this, this pop-up menu. So now you just have to click on a few things. This is where you set your name. So instead of typing it out like we did, what we do is do C_exp. So we can set our name there of our object. Encoding is automatic. You don't need to worry about that. Heading, you want to make sure you put yes, and row name should be automatic. Separator is comma. It's a comma because we're using a comma separated value, a CSV file. So make sure that this is set to comma. Don't have to worry about your decimal should be period. We're not in Europe. And you don't have to worry about the double quote. You shouldn't have to worry about comment. NA strings as NA, you should leave that alone. And strings as factor, if this is clicked on, click it off. It should be defaulted to not be checked. Okay, so really we just leave essentially everything as is, right? And then we can just, it gives us a little preview, so you can also check it that way. And then we just press import. So here it did the same thing, right? Like if we look at what the code that it ran was it set the file name, it did read.csv, and it did our file path. So again, you do not have to type it out completely if you don't want to. If you're more comfortable importing the data set from the drop-down menus, that's okay. Again, I just want people to have as many options as possible so that no one has issues on the exam just trying to load in a file. That shouldn't be where any of the stress is coming from. Okay, next we're going to get to subsetting data frames. There are several ways to do this. So unlike vectors and matrices, there are several ways we can subset our data frame. So the first is very familiar, right? So this works the same, dimension-wise, it works the same as matrices. So you have your rows and your columns. So, and they're separated by a comma within square brackets. So here we're going to just be getting the 7th row. And we can see shows up 7, student name, month, expenditure, and it shows us just the 7th row of our data frame. We can do the same thing we were doing before where we put in a sequence of numbers and it's going to give us those specific rows that we want. So this is going to get us rows 10 through 50 going by 10, incrementing by 10 each time. So this will give us row 10, 20, 30, 40, and 50. And you can see that it does that with our handy little labels and again with our column names. So you can also do this you can subset a little more specifically. So here, what we're going to do is we're going to take our data frame name and then we're going to type it again to indicate that we want the birth month column of this data frame and we want it to equal July. So let me show you what that looks like. So what this is doing is filtering the rows specifically for the birth month equaling July. And so you want to have your comma and your open, just your space here. And the reason for that is we want the rows that of people who are born in July, but we still want to see all columns of information for them. If we didn't, so say maybe we wanted to just see the commute expenditure for people born in July, we could do that by setting this to 3 because it's the 3rd column. And then it'll just give us those two numbers, right? So now it's just giving us this column, but still filtering on birth month equaling July. Okay, so I think the most important thing is that you have to retype the data frame name and then $ and the column you want in order for this filtering to kind of work. So here we're going to do a similar thing, but we're going to filter on expenditure, on commute expenditure. And we're going to want to only look at our rows for people who have commute expenditures lower than 270. And we're going to look at all columns. That's why you have a comma and nothing here for the columns selection. Okay, so now you can see these are all of the people with their birth month who have commute expenditures below 270. We can then set multiple conditions. So this is just one condition. We can set multiple conditions at once. So here what we're doing is we want to look at commute expenditure, and we specifically want to look at those rows where commute expenditure is greater than or equal to 310 and where the commute expenditure is less than or equal to 315. So we're looking at a very small range of commute expenditures. So the and symbol, that's going to be how you combine multiple conditions. And remember, we saw these in the logicals. This and sign came up, and so did our or sign, our straight line. So that's how you're going to set your conditions, the same way that we were setting logical conditions before. So if we take a look at that, we now see that there's actually quite a few people who have commute expenditures between 310 and 315. And here's all their information. Okay, moving on. We have summary statistics for data frames. So very, very simple thing you can do is just run summary on your entire data frame. And it will give you a bunch of information. So here it has, it goes by column. So it has student name. It tells you what the length is. It tells you what class it is and mode. Does the same thing for birth month. And for our numeric column, our actual expenditure column, it gives us some more information in terms of the minimum, median, max, and the quartiles. So this is giving us an idea of the spread of it, or the distribution of it. We can also get some more specific, like more detailed summary statistics. So we can run summary on a specific column if we want to. And you can see it's going to do the same thing that it did here, but it's doing it only for the column we've specified. And again, because commute expenditure is a numeric, we can then run some other things on it. So we can get the standard deviation of it, the variance, and we can do a sum of it, just like we were doing with our vectors. Okay, so moving on to factor types. So one moment. Okay, so one thing is that the example that it's giving in the manual is not the same as what mine has loaded it as. So my R has loaded the birth month column as a character, which is fine. It works as a character. However, in the example in the manual, it was loaded in as a factor. And so that's why the result in the example in the manual looks different, which we'll just go from here and set it as a factor, and that should work pretty much fine. So let's first set it as a factor, and then we'll talk why we're doing that. So here we're going to call our commute expenditure data frame, and then specifically call with our $, our birth month column, and we're going to now convert it to a factor. So the way we do that is we do our assignment operator, factor, and then we type in again the same name of our commute expenditure birth month column, and then we're sorting that factor by month name. Okay, so now that we've done that, we can run summary on it again, and we'll get this, which looks a whole lot different than this, right? So the difference between these is that when R has a factor type of data, it's kind of, it's like in SPSS when we set some of our nominal data, like we set our gender to be like male and female. So with that, there's like two factors or two categories really. So this is basically making a categorical variable out of our data. And because we're doing this, it reads each one as a specific category and can lump them together. So it can lump all the Januaries together, lump all the Februaries together, and give you this summary of each one. And the putting in month.name here, by doing that, we're actually sorting it by the month name. Okay, so the tapply function was mentioned, I didn't mention in the video, but it's mentioned at the end of the last chapter on matrices. And so we're just gonna go over it. It's important that we had this set as a factor actually because of what we're going to do in the tapply function. So with tapply, what we're doing is we want to look at a specific column, we want to group it by another column, and then we want to run a specific function on it. So here, all we're doing is we want to analyze our commute expenditure column. We want to get the mean of it, but we want to do it per category of our factor variable here of birth month. So that's why we put it into a categorical form. This way it can split it up and run tapply properly on it. So if we do this, we can see that it automatically separates our months out because it's a categorical variable. And what it's giving us is the average commute expenditure per each category, so per each month. Okay, so that's the tapply function. Next, we are going to get to creating bar charts and pie charts. I think I'm going to actually have this as a separate video though. So yeah, I'm going to end this one. So the next one will just be like chapter 6.2. I will get to covering just bar charts and pie charts, some pretty simple stuff. And then there'll only be one video after that.